Hello. So in this video, we'll try to state some links between the two different approaches that we previously discussed toward the decision-making problem. Okay, so the first one that we mentioned was the preference-based approach, and later we also introduced the choice-based approach. So today in this video, we'll try to establish the links or the relationship or sort of the equivalency between those two different approaches. Okay, but we need some minor or some additional requirements or some conditions for us to establish those equivalencies. Okay, so before we begin, okay, so this would be the preference-based approach and choice-based approach. Okay, so before we formally begin, we need to give some further definitions on something that are useful for us to later to construct those relationships between those two approaches. Okay, so the first definition will be the definition on the textbook 1.C.2. Okay, so this would be a definition for so-called the revealed preference relation. Okay, so we say that a choice structure, okay, the choice structure, this calligraphic B, and choice rule C. So this, we call this a revealed preference relation. Okay. Okay. So given this, okay. So this is so given a choice structure, okay. So then the revealed preference relation, okay, and we simply use this preference relation and add another star here, okay. So this revealed preference relation is defined as follows. So when we're saying that X is revealed at least as good as Y, okay, so if only if there exists some budget set B such that, okay, for any xy in B, and we always have this X is chosen, okay? So, and that would be the definition for this revealed preference relation, okay? If we say that X is revealed to be preferred to Y, or at least as good as Y, okay? And this is a very straightforward definition from this condition, necessary and sufficient condition, okay? So, and we do not need this revealed preference relation to be either complete or transitive, okay? So, and in particular, for any pair of alternatives, X and Y, to be able to be compared or be comparable, so it is necessary that for some budget set, we have X and Y in the set, and either X is chosen or Y is chosen or both, okay? So that's the basic idea of this. So we may also say that X is revealed preferred to Y if there's some budget set such that XY in this set and X is chosen but Y is not, right? So this is defined analogously, right, to this, as we did in the preference-based approach. Okay, so maybe we could do that definition, right? So if we say that X is revealed preferred to Y, if and only if there is B such that X, Y in B, X is chosen, but Y is not. Okay. All right. Good. So, and then with this terminology, then we can restate the warp from the previous episode, the weak axiom of review preference, as follows. Okay. So warp could be read as follows. So if X is, okay, let's use the notation here. So if X weakly preferred in revealed at least as good as Y, okay, then Y cannot be revealed preferred to X, okay, then this is not true. Okay. All right. Good. So, okay, so that would be the definition for this revealed preference and the weak one or the strong one, right? So we have two definitions here. Okay. Good. So now we are ready to try to analyze some relationships between those two different approaches. Okay, so the preference relation and the choice rules. Okay, so the basic question for this relationship would be that in section 1.d on the textbook, okay, so the authors, they ask that the first question is that if a decision maker has a rational preference, do her decisions when facing choices from the budget sets in the category B necessarily generate a choice structure that satisfies the weak axiom? Okay, so that's this direction. And in the other way around, in the next question, they ask that if an individual's choice behavior for a family of budgets is captured by some choice structure satisfying the weak axiom, the warp, and is there necessarily a rational preference relation that is consistent with the choices? So, and here the answers are that, so the first direction will be yes, but the other way around for the second one will be maybe. Okay, so and later we'll see that so both two directions, they should work, but it's simply that we need some further conditions or further requirements, okay, for those for to establish the equivalency. Okay, it's just that for the first direction, it's simply because that the first direction requires a very minor or very small condition for that to hold, but the other direction, the other around might require a bigger or something more than that. Okay, so later we'll introduce the conditions that we need to put to establish the equivalency between those two approaches. Okay, good. So okay, now we will go directly into the proposition 1.d.1. Okay, and try to answer the first question that we just asked. Okay, so suppose that this is a rational preference relation. Okay. So we want to derive from this to the warp. Okay. Then the choice structure. Okay. Generated by this rational preference. So that'll be this calligraphic B and some revealed preference C star. Okay, so before this, we need to define this C star. Okay, so all right. So let's simply put this just down there. Okay. All right. So let's leave some space and define something that we need for this proposition. Okay. So for the first direction, given some rational preference. Okay. So if we want to derive the choice structure then generated by that rational preference, and that choice structure satisfies the warp, then we need to first define some choice rule. Okay, so let's do this first. So suppose that an individual has a rational preference relation on X. Okay, so again, this will be the rational preference relation. Okay, on X. Okay, so if the individual faces a non-empty subset of alternatives, okay, budget set as a subset of X, then the preference maximizing behavior is to choose any one of the elements in the set. Okay, so this will be defined as this C star, okay, of some budget set B, and using under this preference relation, which is rational. So this is defined as a set. So the element X, little x, okay, so that'll be an element from this budget set, such that this X, element X, it has to be weakly preferred to any element in this B, okay, for every Y in B, okay. So essentially it's saying that X in this B, X should be, so all those elements or the elements that are chosen here in this B is the best one, right? It's mostly preferred. Okay, so the elements of set this C star are decision makers' most preferred alternatives in B, right? As we just mentioned. Good. So, and in principle, we could have that this C star, it might output some empty set, okay, for some B. But if X is finite, or if suitable, let's say some continuity conditions hold, then the C star, it is still non-empty, okay? So we don't actually need to worry about that. So normally this is non-empty if that is finite. X is finite, okay? So, and then we'll consider only the preferences, the preference relation and the families of budget sets, calligraphic B, such that the C star is non-empty for all those budget sets, okay? And we say that the rational preference relation generates the choice structure, okay? So now empty So we only, okay, so we consider non-empty C star, okay, of B and this relation. Okay, so we can say that this rational preference relation, it generates this Chord structure, okay, C star. And it'll be any B from this calligraphic B, right? And this is the preference relation. Okay, good. Then the next will be the proposition 1.d.1, and that'll be telling us that any Chord structure generated by rational preferences necessarily satisfy the Wick axiom. Okay, good. Now let's continue on this. So suppose that this preference relation is rational, then the Chord structure generated by this rational preference relation, and that'll be this thing we just mentioned, right? So this Chord structure, calligraphic B, and this this is C star, and taking all those B's, and with rational preference relation. Okay, so this would be satisfying the warp. Okay, good. Now let's try to prove this. Okay, proof. Okay, so first we suppose that for some B, okay, we have some elements xy, and let's say that x is chosen from the C star, okay, and in this B, you under this rational preference relation. So by the definition we just mentioned for the C star, okay, by the definition of C star, okay, so it simply means that x is weakly better than all elements than y, okay. This gives x is weakly preferred to y, right, for any y in this B. Okay. So then we want to check whether the weak axiom or the warp holds, right? And suppose that for some B prime, okay, suppose for some B prime, okay, another budget set with x and y in B prime. Okay, let's suppose that y is chosen by C star here, okay, for the under this rational preference relation. In this B prime, okay, let's say if y is chosen, then this immediately implies that y must be weakly better than z for all z in B prime, okay. Okay. But we already know that x is weakly preferred to y, okay. So by the transitivity, of this rational preference relation, right? Transitivity. X has to be weakly preferred to Z. Okay. So this means that X is in this C star, right? Of B prime. And then this is exactly the conclusion that the warp demands, right? Okay, good. So then this proposition gives the first direction from the rational preference relation to a choice rule satisfying the warp, right? So, and for the other way around, or in the other direction from the choice rule with warp to some rational preference relations, and then we might need to work on some further conditions, okay, to establish this direction, okay. So now before that, let's first again to try to define some tools or some intermediate steps or something that might be useful for us to later to show the other direction, okay, and that is called rationalize, okay. So this would be the definition 1.d.1. Okay, so we say that given a choice structure, calligraphic B and C map. So, and here we say that the rational preference relation okay, this rationalizes this map C and relative to this B, to this calligraphic B, if something happens, if C of budget set B is exactly the C star we defined of this B under this preference relation, okay, which is rational preference relation, okay, and this is for all B, and that is if this rational preference relation generates the choice structure. Calligraphic B and map C. Okay, so in plain English, the rational preference relation, this rationalizes the choice rule C, this map, on the calligraphic B, if the optimal choices generated by this rational preference relation, and that becomes, or that coincides with this C for all budget sets in the calligraphic B. Okay, good. So that would be the interpretation of this definition, right? So in some sense, the preferences explain the behaviors, right? And then we can interpret the decision maker's choices as if the decision maker were a preference maximizer, okay? And the textbook also said that there might be more than one rationalizing preference relation for a given choice structure, right? And this makes sense. Okay, good. So this proposition, it implies that the weak axiom or the warp must be satisfied if there's to be a rationalizing preference relation, right? And in particular, since this C star satisfies the warp for any preference relation. Okay, only a choice rule that satisfies the warp can be rationalized. Okay, and it turns out, however, that the weak axiom or the warp is not sufficient to ensure the existence of a rationalizing preference relation. Okay, so and later we might need something to together along with warp to be sufficient to be able to derive a rational preference relation. Okay, so before that, let's have a look on some example. Okay, so this will be example from the textbook 1.d.1. Okay, so here we have this x, the set of alternatives to be little x, y, and z. Okay, so here the budget sets, the family of those budget sets, category of B. So this will be including xy, yz, and xz. Okay. And the choices are such that if the budget set is xy, then this person is choosing x. If y and z, then choosing y. If x and z, then choosing x, then choosing z. Okay. And this is obviously satisfied in the warp, okay, because we do not have a repeatedly showing up budget sets, right? So we have completely different budget sets, x, y, y, z, and x, z. Okay, so warp always hold here. However, okay, we cannot have rationalizing preferences. Okay, so and then here to see this, then we could so we can see that in order to rationalize the choices under x, y, and y, z, it will be necessary for us to have x is strictly preferred to y and y is strictly preferred to z. Then immediately we know that x is strictly preferred to z, right? And that would be contradictory to the choice behavior under x and z, right? So there will be no rationalizing preference release. Okay, good. So next we'll try to establish the other direction that we mentioned using the warp for a choice structure and to try to derive some rational preference relation. But that as we just mentioned, that is not that was not sufficient, right? So we want to have some additional condition to be satisfied, to be sufficient. Okay, along with the warp. Okay, so now let's have a look. So this would be the proposition 1.d.2. Okay. So it says if this choice structure, categorical B and map C, if this is a choice structure such that, okay, so first requirement is warp holds. Okay. And second is that now we have something that might look pretty strange, okay, but later we'll see the intuition behind this requirement. Okay, so it'll be this calligraphic B. It includes all subsets of X of up to 3 elements. Okay, so we want to put all those possible subsets that has 1 or 2 or 3 elements. So it's up to 3, right? So 1, 2, or 3. Okay, so then there will be irrational preference relation. Okay, that rationalizes the choice rule C and under or relative to the calligraphic B. Okay, so in other words, that is C of B is this C star. Okay, good. And this is for all B's. And furthermore, this rational preference relation is the only preference relation that does so. Okay. All right. So now let's try to prove this. Okay. So we'll be using this revealed preference relation, right? So that's sort of a bridge for us to establish this connection. So the natural the candidate for a rationalizing preference relation is the revealed preference relation, right? So to prove this result, we must first show two things. Okay, so first is that this revealed preference relation, okay, to show first the revealed preference relation is a rational preference relation, okay? And second, this revealed preference relation, it rationalizes this choice rule on this calligraphic B, okay? So that rationalizes this on this, okay? And then third, and lastly, we want to show that this is unique preference that can do this, okay? Good. So now let's do this one by one and begin with the first point. So the first point is we want to check that this the revealed preference, the star preference relation, is indeed rational. Okay, so we'll check the completeness and transitivity. So first is the completeness. Okay, so given the second assumption or the second condition in this proposition, so the thing that up to 3 elements, right? So that condition, so we have, let's say, X and Y. This subset, this would be one element in this calligraphic B, okay? And since either X or Y must be an element of this non-empty C, right? Because this is non-empty, as we mentioned, for some reason. So it has to have some value, right? So we must have X, okay, is reviewed preferred to weakly preferred to Y, or Y reviewed weakly preferred to X, or both, right? And then this completes the proof for the completeness, okay? All right, so that's the completeness. How about the transitivity? Okay, so as for the transitivity, so that'll be a bit longer. Okay, so this proof. So first let's say that X. Suppose X is weakly revealed preferred to Y, and Y is weakly revealed preferred to Z. Okay, so because we want to show the transitivity, right? So now we go back to the let's say consider some budget set. Okay, so let's put all of those X and Y, Z. Okay, in this category of B. So this would be a one element of that, right? So let's consider this set. And it suffices to prove that X is chosen, okay, from this budget. Since this is implied, by the definition of this revealed preference, that X is weakly revealed preferred to Z. Okay, and again, because this C of X, Y, Z, this cannot be empty. So at least one of the alternatives X, Y, or Z must be an element of this map C, right? After the map C must be an element of this, right? Okay, so and now we suppose that Y is chosen here. Okay, so suppose Y is chosen. Okay, and because X is revealed preferred to Y weakly. Okay, so let's using warp. It gives us that X has to be also chosen, right? Okay. And let's suppose instead Z is chosen, okay? And again, because Y is weakly revealed preferred to Z, then using warp, it gives us that Y is chosen as well. Okay. Good. Then if this is the case, then we're in the previous case. Then this completes the proof for the transitivity, right? Okay, good. So that'll be the first point to show that the revealed preference relation is rational. Okay, good. So let's go to the second step to show that this revealed preference relation that rationalizes this choice structure or this choice rule. Okay. Point 2. Okay, good. So now we want to show that this CB it is exactly the C star of B given this revealed preference relation. Okay, and this is for all the B's. Okay, and that is this revealed preference relation inferred from this choice C, from the map C, actually generates C itself. Okay. All right. So intuitively, this looks sensible. It makes sense. Okay. So then, formally, how do we show this? Right. So we'll again we will show this in 2 steps. Okay. So first, we suppose that, let's say X is chosen in this B. Okay. Then using X is weakly revealed preferred to Y for all the Y's. So we have that X is in the C star. Okay. And this means that the CB is a subset of C star. Okay, good. And then suppose X is in the C star. And then this implies X is weakly revealed preferred to Y for all Y in B. And then so for each Y in B, okay, there must exist some set, let's say this is called BY, okay, such that X, Y is in BY. And X is in C of BY. Okay. Again, because this C cannot be empty, okay, it has to have some values. Then we use warp. It gives us that X is in C. Okay. Then we show that C star is a subset of CP. Okay. Okay. now CB is a subset of C star, and then C star is a subset of CB, then it simply means that CB is exactly C star. Okay, good. And this is a very interesting proof, right? So we go all the way and to show this equation, and by showing that each of those two are the subset of the other one, right? To show the equation here. Okay, good. So that would be the second point. And further, we want to show that this is unique, right? Okay, so to establish this uniqueness, okay, and this is simple to just notice that because this calligraphic B, okay, so it includes all the 2-element subsets of X, okay, and the choice behavior in C, then the choice behavior in map C, that completely determines or pins down the pairwise, so between 2 elements, right? The pairwise preference relations. Over X of any rationalizing preference. Okay, then this is unique, and then we this completes the proof. Okay. All right. So now let's go back and have another look in this proposition. So in this proposition, it simply goes from the other direction, right? So it starts from the warp for the sum choice structure, calligraphic B, and some choice root C. So and why do we need some further assumption that this calligraphic B includes all subsets of X of up to 3 elements, right? So we can see from this mathematical proofs, but intuitively, as long as we have the elements with 3 elements for this in the subset, right, as an element in this calligraph B, then in this case, we could always compare, or we can establish the choice between each 2 of them, right? And then this would be we can always review or to show the behavior of the choices in pairwise, as we just mentioned, right? So and then up to 3 elements, then this would be indeed this would be really helpful for us to further have this result to hold for this rational preference relation, right? Okay, good. So those proofs are quite useful to establish the equivalencies between those 2 approaches, but keep in mind that there are some minor assumptions further required to establish those relationships. Okay. All right. Good. So this would be the connections between the choice-based approach and preference-based approach. Okay. And later we'll try to show some properties of the those approaches, and then try to introduce a more convenient way to represent the individual's decision making, which is the utility. Okay, good.